these questions from the chapter 4 probability practice test. This is Little Crow. And let's go ahead and take a look at question number 1. We've got the probability distribution of blood types for 100 Americans is listed in the table. If one donor is selected at random, find the probability of selecting a person with blood type A plus or A minus. This is an OR probability, probability A plus or A minus. So we need to add, or means to add, and possibly subtract if there's any overlap. However, if you're either A plus or you're A minus, so there is no overlap, this is out of 100 Americans. You might want to double check and just make sure that this is all accounted for, but 37, 36, 34. So there's 40, 77, 87, 97 plus 3 is 100. Okay, added them all up. So it's going to be 34 plus 6 all over 100, which is 40 over 100, which is 0.4. It's this one right here, D. Write the word or phrase that best completes each statement or answers the question. The data in the table represent the number of consumer complaints against major U.S. airlines. If one complaint from the table is randomly selected, find the probability that it was filed against Northwest Airlines. So here's Northwest Airlines. We reach in that band, there's a possibility there's 765 letters that are complaining about Northwest Airlines out of what's the total. That's the thing we need to get. So let's add these up. We've got, let's clear this out second. Here. Shift, clear. So 1172 plus 765 plus 563, 2,500. And so you could just leave it, but 765 2,500. We could also do it as a reduced fraction, 153 out of 500. Personally, I like this because it tells me I can see the 765 there, verify it, so that's kind of a nice number. Or the other one I like is a decimal because I can understand it better. About 30%, right? 0.306 or 30.6%. These are all acceptable answers. Yeah, all of them. I would accept any of them because it didn't, first of all, it didn't say how you had to put it anyway. Okay. Let's keep going down. Question 3. Singer-songwriter wishes to compose a melody. Each note in the melody must be one of the 13 notes in her vocal range. She's only got 13 notes. I don't know that that's very many for a singer, but anyway, we'll go on. How many different sequences of 4 notes are possible? So 4 notes, 1, 2, 3, 4. She's got 13 notes, so we've got 13 for the first one. They don't say that she can't reuse them, right? She could use those. She's only got 13 notes that she can sing, but she could use the same note again and again and again. So we get 13 to the 4th power, which is going to give us 13 raised to the 4th power. It's going to give us 28,561. Option B. Okay. If you did a permutation because you thought maybe she can't repeat the notes, didn't say that, you would have gotten the answer D. So that's why that D is not correct. Provide an appropriate response. Classify the events as dependent or independent. Events A and B, probability of A is 0.7, probability B is 0.6, probability A and B is 0.4. Okay. So are they independent or dependent? Well, if they're independent, that means that if you take probability A times probability B, that's going to be the same thing as a probability of A and B. Because the probability of A happening does not change or does not do anything with B. So we could just multiply the probabilities. So probability of A times the probability of B is equal to the probability of A and B if they're independent. So let's see. It's 0.7 times 0.6. Is that equal to 41? No, it's equal to 0.42. So they are not independent. They have to be dependent because these two are not equal. Okay, so we're going to go with B. A group of students were asked if they carry a credit card. The responses are listed in the table. We've got this here. Let's come up a little bit. We got this table here. If a student is selected at random, find the probability that he or she owns a credit card given that the student is a sophomore. Round your answer to 3 decimal places. The given is a conditional. We know the student is a sophomore, so that means we're only dealing with the numbers in this horizontal stretch. We get to ignore anything about freshmen because freshmen are not considered. So these totals don't exist, only these numbers. 40 carry a credit card. That's what we probably that he or she owns a credit card. So that's 40 out of 40, which equals 1. D. Okay. Conditional probability. 6. You are dealt 2 cards successively without replacement from a standard deck of 52 playing cards. Find the probability that the first card is a 2 and the second card a 10. Round your answer to the nearest decimal. 2 cards successively without replacement. Okay, so 1 card, 2 cards, and we're going to use the multiplication principle here. Probability the first card is a 2. Well, how many 2s are there? There are 4 2s in a deck and out of 52 cards. So let's say we got dealt a 2, whatever you get dealt. So there's 1 less card. And now the second card being a 10, how many 10s are there? Well, there would be 4 10s because we drew a 2 out of 51 cards. And then we multiply that. 4 divided by 52 times 4 divided by 51. It's 0.006. Notice there's nothing even close there. Now, if you put a 4 over 52, you would have got close enough. You should still be able to get this 0.006. But yeah, that's the correct way to do this one. Also, if you weren't really sure, just look at the answers. This is almost 100%. No, that can't be. 50% getting a 2 and a 10. I don't think so. That doesn't sound and even 25% chance doesn't sound good. So if you get a little bit a feeling for how probabilities work. The probability it will rain is 40% each day over a 3-day period. Doesn't change. What is the probability it will rain at least one of these 3 days? Now, this is a little complicated. If you try to follow this, you got your 3 days. At least one means it rains on 1 day, 2 days, or 3 days. And, there's a couple different ones you have to look at. When you have this at least one, a lot of times, and in this case especially, it's easier to solve none and then subtract that from 1, right? It's look for the complement. So what is the probability it will not rain on any of the 3 days? Well, chance of rain is 40%. Chance of rain of not rain is 60%. So we could calculate that it's not going to rain on any of the days. Would be 0.6, 0.6, 0.6. So we could take 0.6 raised to the third power. We get 0.216, so about 21%. This is not what we want. That's the complement of what we want. So then we take 1 minus 0.216. So 1 minus the answer, 0.784. Probability rain at least on one of the days. Okay. Card is drawn from a standard deck of 52 playing cards. Find the probability that the card is an ace or a heart. It's an or probability, ace or a heart. So or probabilities we add and potentially subtract. Probability of being an ace, there are 4 aces out of 52. Probability being a heart, there are 13 hearts. There are 13 of every suit, so 13 out of 52. But we have to remember to subtract off the heart that is an ace, the ace of hearts, right? Because that got counted twice in both of these. So we subtract 1 out of 52. That's 17, or 17 minus 1 is 16 out of 52. You don't see it here because it will reduce 16 divided by 52, and it reduces it down to 4/13, which is this answer right here. Okay. The table lists the smoking habits of a group of college students. Not a good idea to smoke either way. If a student is chosen at random, find the probability of getting someone who is a regular or heavy smoker. Or probabilities are going to be addition and possibly subtraction if there's an overlap. Regular smokers, here's a regular smokers, that's this way. Heavy smokers, that's this way. So there are no overlaps. And so we can just add. So the total of regular smokers, regardless of male or female, is 87 out of 420. And heavy smokers are 11 out of 420. There's nothing to subtract off because there's no overlap. So we get 98 out of 420. They want the decimal, so we go ahead and do that. 98 divided by 420 gives us 7/30, but the decimal is 0.233333. Looks like here, B. Perform the indicated calculation. So in this one, we want to do a permutation. We hit the toolbox, go down to probability, we go over to combinatorics, we hit OK, and we want a permutation. We want 10 things, choosing 5 at a time. Hit enter. 30,240. It's going to be a lot. In fact, actually, if you looked at this, you might have just said, well, it's a permutation of 10 things. It's going to be a lot of stuff. This is it. C. Now, if you've got the TI-84 calculator, the other ones, I didn't do those separately calculated, but let me go ahead and do one with the TI calculator, just because it's a little different. Okay, so a permutation on the TI calculator. Let's see, let's go quit. Let's clear. Where you get that is you go to the math key, you go over to probability, enter. No, not enter, because that's random. We go to math, probability, and then you have to go down, NPR. Now, depending on, you may have to put in the number first, the 10 first. So let me kind of do that. Put in the 10, math, probability. If you don't have to, you could actually go back and do that, but many of you have a calculator that you have to do that. Put in the 5, and you see again 30,240. And that was our last question. Let's see, do I have a answer key here? I do. That was number C. So you can check out the answer key and go through each of these. Hopefully I got them all right myself. Again, 270. Yeah, I think we're pretty good. Let's see, 7 was 0.7. Yeah, I think we're pretty good all the way along. Let me know if there's any issues. I guess, again, occasionally I slip up, as you see, but I want you to be thinking through them, and there we go. So that's the practice test for chapter 4.